Okay, in this video, I'm going to show you how to solve the pulley problems that you were assigned in class and in homework. So let's go ahead and take a look at the first one. Okay, so the first problem says a construction crew lifts approximately 560 pounds of material several times during a day from a flatbed truck to a 32-foot rooftop. A block and tackle system with 50 pounds of effort force is designed to lift the materials. Okay, so we know we're dealing with the block and tackle system, but it doesn't tell us how many pulleys are actually involved in the block and tackle system. Okay, let's see what else we know. It tells us that the crew lifts approximately 560 pounds of material. So if that's what they're lifting, we know that's going to be our FR. And it also says it gives us 50 pounds of effort force. So we know this is going to be our FE. Okay. And it says material several times during a day from a flatbed truck to a 32-foot rooftop. Okay. So let's think about that a little bit. But let's go ahead and look at the first problem first. What is the required actual mechanical advantage? So here we're trying to solve for the AMA, right? And we know that our AMA, right, is equal to the FR over the FE. Okay, and that we know because we've already identified, right? We know that our FR, we said, was 560 pounds. And we said our FE was 50 pounds. Right, so if we just divide 560 divided by 50, we come up with an AMA is equal to 11.2. Okay, so the next one says how many supporting strands will be needed in the pulley system. Okay, so that pretty much tells us what we already knew, is that we don't know how many pulleys are in the system, so we don't know how many supporting strands are going to be. Okay, so it's asking us that. All right, so the first thing I would do is I would probably draw a sketch. I know we don't know how many pulleys are going to be involved in the system, but we can at least draw a simple sketch of what a block and tackle system might look like, right? So we know it would involve at least 2 or more pulleys. Okay, so let's go ahead and draw it, assuming that there's going to be 2, right? And then we know the load is going to be here. Okay, and this is our FR. Right. So then we know that the string would come here, it would come around, it would go this way, and it would do something like that. Okay. Okay, so we know our FE and we know our FR. Okay, so the formula that we're going to use to solve for the unknown is the same formula we've been using over and over again, which is our equilibrium equation, right? Okay. So it says, what value we do know is it says that the material is being lifted several times during a day from a flatbed truck to a 32-foot rooftop. Okay. So one thing in a pulley system is that when we define the DE and the DR for a pulley system, it's a little different than the way it is for a wheel and axle and for a lever system, okay? The DE, remember, is always measured from, in the wheel and axle and the lever, from the fulcrum to the force effort, right? So in this particular case, if this is our fulcrum here, right? And what our FE will essentially be is the amount of rope that's going to be pulled in order to lift the force resistance, right? So if I start here and I'm pulling on this rope, right? And I pull, let's say, I don't know, I pull about 3 feet of rope, okay, as I'm pulling down. Now that would actually be my DE, right? And then my DR would be the amount of rope that would be pulled within the block and tackle system, right? So in this particular example, it would be my DR would be here. So the amount of string or rope that we're going to pull is going to be longer for your DE than it will be for your DR. And remember, go back to what we know about a lever. You have to manipulate the distance, remember, in order to actually be able to lift more weight compared to the effort force that you're applying. So this is also true for the pulleys. You have to pull more rope if you want to apply less effort, but in this particular case, the force resistance is going to require, since it's heavier here, is going to require less rope. Okay, so when it asks us that the material is lifted from a flatbed truck to a 32-foot rooftop, okay, what they're actually talking about is going to be the DE. Okay, so the amount of rope that we're going to have to pull is going to be 32 feet. Okay, so what we're actually solving for is going to be our DR. So our DR would be FE times DE all divided by FR. Okay, and when we plug what we know into the equation, that would give us a DR equals to 2.86 feet. That's our DR. Okay, so you could see that when we're pulling on our effort force, the amount of rope we have to pull is 32 feet, but the amount of rope that's actually being pulled within the block and tackle system is only going to be 2.86 feet. Okay. Now, that doesn't actually solve our problem, right? Because it says it wants to know the number of supporting strands. So the other thing we need to do is we need to look at our IMA, right? Remember, our IMA is DE over our DR, right? And also remember, for a pulley system, the IMA is also equal to the number of supporting strands. Remember that equation? Right? So if we know our DE and our DR, remember our DE is 32 feet, we know our DR is 2.86 feet. If we divide the two, then we come up with an IMA equals to 11.2. Okay, so this would also equal to 11.2. So what we would have is we would need 11 to 12 supporting strands. Okay, and that's our answer. Okay, so the next problem states that we have a block and tackle system with 9 supporting strands. Let me erase all this here. Okay, so we have a block and tackle system with 9 supporting strands used to lift a metal lathe in a manufacturing facility. Okay, so a metal lathe is just a machine used to actually cut off material from an object. So it says the motor being used to wind the cable in the pulley system can provide a 100-pound force. Okay. So we already know that the equation that we're going to have to use is, again, our equilibrium equation. Okay. And, well, actually, let me jumping ahead of myself here. This one wants to know the mechanical advantage of the system, right? And the mechanical advantage of the system the IMA is going to be the number of supporting strands. Remember that? Okay, so if it tells us we have 9 supporting strands, then we know our AMA is going to be equal to 9, right? Okay, so that one was easy. Now it says the maximum weight of the lathe. Okay, so now we want to use our equilibrium equation times dr, okay? And it says the maximum weight. So what we're solving for, right? It says the pulley system can provide 100 pound of force, so that's going to be our FE, all right? So we know our FE will equal to 100 pounds, right? And we're trying to solve for our FR, which is our maximum weight. So that would be FR would be equal to FE times DE all divided by DR, okay? Now this is a little tricky because we know our FE equation, right? I mean, we know our FE value. We just said that that was going to be equal to 100. But we don't know our DE and we don't know our DR. Okay? So we have to think about the relationship between the two. And we know that the relationship between the two is going to be IMA is equal to DE over DR, right? Or the number of supporting strands. Okay, so either or. So we know our IMA is equal to 9, right? So IMA is equal to 9. So 9 is equal to DE over DR, all right? So now we have a relationship between the DE and the DR, okay? So what we could do is we could say, just by simple algebra, let me redo this. If 9 is equal to DE over DR, then we could say that DE, just rearranging this by using algebra, is equal to 9 DR, right? So if we plug that into our equation here, and we say we know this is 100, we know our DE now, right, is 9 DR divided by DR. And then using algebra, we know we can cross these out. And what we're left with is 100 times 9, and that gives us 900 pounds, right? So our FR will equal to 900 pounds, okay? All right, so that's it.